Hi, this is Esther Park, and I'll be having a presentation about a lab that I've done. First, I will have a quick introduction of this video, then talk about important physics concepts that will be used throughout the video. Also, I will build an experimental and computational model and compare those two models. After, I will talk about possible sources of error and answer questions on what if and what does it mean. The purpose of this lab is to analyze the motion of an object moving at a constant speed and compare an experimental model with a computational model and identify possible sources of error. The main concept introduced in this lab is Newton's laws of motion. The first law of motion states that every object will remain at rest or in uniform motion in a straight line unless an external force acts on it. In this lab, during motion, no other external forces were applied, meaning that the object will have a uniform motion in a straight line. Also, according to Newton's second law of motion, the acceleration of an object is directly proportional to the net force acting on it. Since the net force is zero, the acceleration of an object is zero. In other words, the change in velocity is zero, so the object is expected to move at constant velocity. There are two main formulas that were used in this lab. One is the impulse momentum theorem and the other is the position update formula. With the impulse momentum theorem, the change in velocity will be calculated, which will be used in the position update formula to predict the position. This is a video of a lab. The system is a lipstick, and the surrounding is a desk area around the lipstick. In this lab, air resistance and friction are assumed to be negligible. This is the initial position of the lipstick. A red small circle on the lipstick is a point mass, and the motion of the lipstick will be analyzed through the motion of this point mass. The motion of the lipstick was analyzed for 2.667 seconds. Overall, the graph shows that the position increases as time increases. This is the code I wrote to build the computational model for the object. First of all, I set the initial velocity vector to 0.09, 0,0, which was calculated based on how far the lipstick traveled for 0.1 seconds. Also, the while loop is working for the condition of t less than 2.667 seconds because it is the duration of time the lipstick traveled. I updated the velocity vector first using the impulse momentum theorem, and I updated the position using the position update formula, which was aforementioned. And this is the position time graph generated based on the code. The blue graph represents the observed result, which is the same as the experimental model, and the red graph represents the predicted result, which is the same as the computational model. When comparing those two graphs, it is shown that the velocity is overestimated as the observed graph is located above the predicted graph. There are two possible sources of error. First, during the motion, no external forces were applied. However, if the force of push in the beginning is greater than the friction, the net force could be positive, meaning that the object has a positive acceleration. This could result in an increase in velocity as the object moves to the right and the overestimation of the result happens. Second of all, the observed graph is drawn based on the change in motion of point mass. Point mass was marked by a human, meaning that there could have been a random error which results in the overestimation of the results. There are two questions that can be addressed for this lab. First, what if plus x and minus x were interchanged? If plus x and negative x were interchanged, then it means that the position of my object goes in the negative x direction. Therefore, the position time graph will look like y equals negative x, so that the position decreases as time increases. Second, what does it mean by zero net force on the object during motion? Friction and applied force are in the same magnitude but in the opposite direction, so that the x components of the forces cancel out. Also, the force of gravity and the normal force cancel out each other, making the y component of the net force zero. Thank you for listening to my presentation, and this was Esther.